Décollage.
The Baby Colombo mission to Mercury is off to a successful start. These images from the NASA Messenger mission are the best we have of Mercury. It has highlands and lowlands like other planets, but unlike Earth, Mercury rotates on an axis perpendicular to its orbit.
800 degrees. That's how hot this planet gets during the day. Hot enough to melt metal. Hot enough to destroy almost anything exposed to its surface. And then, when night falls, it crashes to minus 290 degrees. On the same world, a place where heat and cold exist in violent extremes. A planet that is shrinking, cracking apart, and slowly tearing its own surface into massive cliffs. A world that leaves behind a glowing trail of atoms stretching millions of miles into space. Almost like a comet. And right now, a spacecraft is orbiting it, studying it in detail. And what it's discovering is forcing scientists to rethink everything they thought they knew about how planets evolve. This is Mercury, the smallest planet in our solar system, only slightly larger than Earth's moon, yet moving faster than any other planet, completing a full orbit around the Sun in just 88 days. It sits incredibly close to the Sun, so close that sunlight reaches it in just over 3 minutes. And yet, despite that extreme proximity, Mercury is not the hottest planet. That title belongs to Venus, whose thick atmosphere traps heat far more effectively. Mercury has no moons, no rings, and almost no atmosphere. Only a thin exosphere constantly blasted away by solar radiation. For centuries, it remained one of the least understood worlds, difficult to observe and even harder to reach. But the few missions that made it there completely changed our understanding of this planet. Imagine standing on Mercury's surface. Above you, the Sun appears more than 3 times larger than it does from Earth, dominating the sky. The ground beneath your feet is scorching, glowing with heat. But then, slowly, night begins to fall. And because Mercury has almost no atmosphere to hold onto that heat, temperatures collapse rapidly, dropping hundreds of degrees. No other planet in the solar system experiences temperature swings this extreme. But Mercury becomes even stranger. Because of its unusual orbit and a unique rotational pattern, something incredible happens. In certain regions, the Sun appears to rise above the horizon, slow down, stop reverse direction, dip back below the horizon, and then rise again. 2 sunrises in the same day. A phenomenon that exists nowhere else in the solar system. And despite all that heat, Mercury hides something unexpected: ice. Real, frozen water, locked deep inside permanently shadowed craters near its poles, where sunlight has not reached for billions of years. Ice, surviving on the closest planet to the Sun. It's one of the most surprising discoveries ever made about this world. But the surface is only part of the story. Mercury's interior is even more extreme. Its iron core makes up about 85% of the planet's radius, far larger than scientists expected for a planet of its size. This enormous core still generates a magnetic field. It's weak compared to Earth's, but strong enough to interact with the solar wind, producing strange and powerful effects, including X-ray auroras, bursts of high-energy radiation invisible to human eyes, yet scientifically extraordinary. This leads to one of the biggest mysteries surrounding Mercury. How did it form? Because a planet this dense, this metal-rich, simply should not exist in this way. One theory suggests Mercury formed farther away from the Sun, and later migrated inward over millions of years. Another theory points to something far more violent, a massive collision early in the solar system's history, a giant impact that stripped away most of Mercury's outer layers, leaving behind its massive iron core, a planetary-scale catastrophe that reshaped the entire world. Evidence of this violent past still exists today, carved into the surface in the form of enormous impact basins, some stretching nearly 1,000 miles across. For a long time, scientists believed Mercury was a dead planet, a frozen, inactive relic from the early solar system. But that assumption turned out to be wrong. Mercury is still changing. As its massive core slowly cools, it contracts, and as it contracts, the surface is forced to adjust. It buckles, it cracks, and it forms enormous cliffs, some stretching for hundreds of miles across the landscape. And surprisingly, many of these features are relatively young in geological terms. That means Mercury is still shrinking, still evolving, even today. And there's more. Mercury is constantly being bombarded by solar radiation, which strips atoms from its surface and sends them streaming into space. This creates a long, glowing sodium tail that stretches millions of miles behind the planet, making it behave in some ways like a comet. At the same time, strange surface features known as hollows are continuing to form, as materials beneath the surface vaporize and escape, causing the ground above to collapse. These processes suggest that Mercury is not a dead world. It is active, dynamic, and still undergoing change. So step back and think about what this really means. The smallest planet, the fastest orbit, the most extreme temperature swings in the solar system, a massive iron core that dominates its structure, a surface that is cracking and shifting even now, a comet like tail stretching into space, and a world that continues to evolve billions of years after its formation. Mercury is not just another planet. It is a living record of the forces that shaped the inner solar system. And with missions like Bepi-Colombo, studying it in greater detail than ever before, we are only beginning to understand its secrets. The deeper we look, the more complex it becomes, and the more it challenges everything we thought we knew. If this made you see the solar system differently, don't forget to like, subscribe, and comment, because there are many more stories like this waiting to be explored.